Earth's magnetic field varies from point to point in space, does it also change with time? If so, on what time scale does it change appreciably? So answer is Earth's magnetic field changes with time. It takes few hundred years to change by an appreciable amount. Why? Because of there is inter numbers of changes of charges on the Earth. If charges on the Earth somehow it is changed by some external effects, then magnetic field also with change with the time, right? So the variation in Earth's magnetic field with time cannot be neglected. And then B question, the Earth's core is known to contain iron, yet geologists do not regard this as a source of Earth's magnetism. Why? So Earth's core contains molten iron. This form of iron is not ferromagnetic, hence this is not considered as a source of Earth's magnetism. Yes, then the charge current in the outer conducting regions of the Earth's core are thought to be responsible for Earth's magnetism. What might be the battery, for example, the source of energy to sustain these currents? So the radioactivity in Earth's interior is the source of energy that sustains the currents in the outer conducting regions of the Earth's core. These charge currents are considered to be responsible for Earth's magnetism. So here charge currents are considered responsible for Earth's magnetism, right? The Earth may have even reversed the direction of its field several times during its history of 4 to 5 million years. How can geologists know about the Earth's field in such distant past? So Earth reversed the direction of field several times during history of 4 to 5 billion years. These magnetic fields got weakly recorded in rocks during their solidification. One can get clues about the geomagnetic history from the analysis of this rock magnetism, because see, these rocks are like magnetic material. So because of the change of Earth's magnetism, this rock the scientists can also find that weakness of that magnetic field of that rock. So by analysis we can find the how many times magnetic field reversed. Then next, the Earth's field departs from its dipole shape substantially at large distances greater about 30,000 km. What agencies may be responsible for this distortion? So Earth's field departs from its dipole shape substantially at large distance greater than because presence of ionosphere. In this region, Earth's field gets more modified because of field of single ions. While in motion, these ions produce the magnetic field associated with them. And now interstellar space has an extremely weak magnetic field of the order of 10 raised to minus 12 Tesla. Can such a weak field be of any significant consequences? Explain. See, an extremely weak magnetic field can bend charged particles moving in a circle. So this may not be noticeable for a large radius path. With reference to the gigantic interstellar space, the deflection can affect the passage of charged particles.